Welcome to all. As a continuation of our fuel and combustion chapter, now we are going to discuss about the crude oil and its distillation process for the petroleum refinery and its uses for further applications. Then we are going to that combustion technology. So these are the brief outline of this class. First, we have to know what is the crude oil and what are the combustion. Crude oils are nothing but which is derived from the natural resources. So the combination of crude oils is which is containing 80 to 87 percentage of carbon and 11 to 15 percentage of hydrogen and 0.1 to 3.4 percentage of sulfur and very less amount of oxygen and nitrogen, which are all seen here. So depending upon this composition, this crude oil is getting from the natural resources, and the percentage of carbon is varying depending in the fractional distillation processes. So wherever we are getting that number of carbons as in the chain, so we may get different products in during the fractional distillation process. Okay, now we have to know what is that fractional distillation. Fractional distillation is nothing but the process to separate its components from a mixture by using the temperature. So here crude oil is going to heated and it is separated by different temperatures. So while applying the temperatures, the parts which is our components which is available in that crude oil is getting vaporized, then it is separated into as a different fractions. So this is the process of fractional distillation of petroleum. So in fractional distillation procedure, we are getting a small molecules to large molecules during its the temperature variations. In the temperature variation itself, so in at 25 degrees Celsius as in the room temperature, so we may get some gases. Then up to 350 degrees Celsius we may get some other liquids or residues as a byproducts. In this case itself, crude oil is inserted in the chamber and it is heated in a tower. In that we have different trays for getting its residues as in the case of fractions. So first we are introducing the crude oil and it is heated up to 350 degrees Celsius or around 400 degrees Celsius. This liquid, that crude oil, is getting evaporated and the fumes are the fumes are condensed at different fractions at each temperature. So in this case the fumes condensed at the around 40 degrees Celsius, which is having that gas, that is the general gas, and around 40 degree to 205 degrees Celsius it is a petrol, and 60 to 100 degrees Celsius is a naphtha, and 175 to 325 is a kerosene, and 250 to 350 degrees Celsius is diesel, and 300 to 370 is a lubricant oil, 370 to 600 is a fuel oil, and finally we are getting that residue at above the 600 degrees Celsius. So in this temperature itself we may get a different fractions. In those things what we are getting is which are the small molecules at the lower temperature and large molecules at the higher temperature. So in those case, at small molecules at in the lowest temperature we are getting the lowest boiling point, very volatile in nature and easier to ignite, flows easily. So due to these cases the gas, petrol and kerosene or diesel like that material, that means naphtha, and these materials are getting easily volatile and also they are having the high flammable nature. So in that large molecules like which are having the high boiling point, that are not very volatile and harder to ignite. They does not flow easily. So these are the molecules coming under the category of fuel oil and residues. Residues are nothing but the asphalt, which is our bitumen, which are as the final byproduct in the fractional distillation. So in this system itself, what we are getting that gas is a bottled gas. So we may use as a household purposes and some other uses in cars and so on. And that second fraction is the petrol, which is nothing but as gasoline. So we may use this in the car as a fuel. And that's third one is the naphtha. Naphtha is nothing but a composition of chemicals. So we may use this one for the manufacturing of some other chemicals. Then the fourth one is the kerosene. Kerosene we are using as a simple in our household appliances up to that aeroplane. That means the aircraft jet fuel as a, and paraffin for the lighting and heating purposes. Then the diesel. The another byproduct is diesel, which is used for high truck based engines. That means the diesel fuels. And that lubricating oil, which are using the lubricating oil and as well as waxes to polishing the surfaces of the automobiles and so on. And the fuel oil, which is mainly used in the ships and factories and central heating purposes. So wherever the maximum efficiency is needed, that means the higher load is applied in that instruments, that means vehicles or other machineries, this kind of the fuel oil is using. And the final product is the bitumen, which is used to make a roads and roofing. Then depending upon this concentration of uh, carbon, so we may classify it as into the different cases which are also deriving from that crude oil. So in this case we already discussed about the temperature is around 25 degrees Celsius as in the cool as in the room temperature. And in the case of hot we are telling about the 400 degrees Celsius. So wherever this temperature is normal, that gas is getting condensed in that first column itself. So which are is nothing but a simple gases which is having that carbons of C1 to C4. So that carbon chain is containing up to 4 carbons, so which are coming under the category of gases. And the second one is the gasoline, which is having the number of carbons as C5 to C6. Then C6 to C10 is called as naphtha material, and C10 to C16 is usually called as kerosene. And diesel is coming under the category of C16 to C20. Lubricating oil is the C20 to C30. And fuel oil is we know that it is a mixture of many carbons, and it is having a lengthy nature of carbon chain. So it is having the C32 C40, and we know that it is hard to ignite also. So it is having high viscosity like that material. And the final one is the crude oil, which is used. The final one is the paraffin wax and bitumen. Paraffin wax is coming under C2, C42, C50, and the waste material which is also uses in that asphalt, so which is called as bitumen. So that is having C50 upwards. So more than C carbon 50 number of more than number of carbons as 50, which is called as bitumen. So that while increasing that carbon numbers, the viscosity and the boiling point also increases. So these are the main criteria to find out which one is the good fuel for our purposes. Then classification of petroleum. So petroleum is classified into three types. Generally, it is classified into three types. One is paraffin based, and the second one is naphthenic based, naphthenic or asphaltic. So third one is the mixed base. So the thing, paraffin based is the composition of saturated hydrocarbons. CH4 to C35H72. So these are the main composition of saturated hydrocarbon with a small amount of naphthalene and aromatics. So as in the case of naphthenic and asphaltic also, which is containing the cycloparaffins or naphthenes. So in the mixed phase itself, these are containing that both of paraffin based and naphthenic based. So this is called the first mixture of first two things. So these are the general procedure for the classification. And the one more process of separation of petrol from water from petrol is called as the demulsification. Demulsification is the process of separation of water. So this process is called as a Cottrell process. In this process, some electrostatic precipitator used. Electrostatic precipitator used. So electrostatic precipitator is nothing but the the petrol plus water mixture is thrown into the tube which is containing that two dielectric. In that itself we are applying here some electrostatic attraction between the two systems, and in those cases the water molecules, that means a small water molecules are coming together from the inlet itself with petrol. That small molecules will combine each other to make a big water molecule, and it is attracted towards the any one type of the electrode. This is the simple process of electrostatic precipitation. By using this method, we may remove the bulk water molecules from those system itself. And and another one case of the removal of impurities, removal of harmful impurities. In most of the in petrol itself, the most available impurity is the sulfur, so which is commonly removed with the some amount of either copper oxide or copper based materials, copper oxides or copper based materials. So simply this copper react with sulfur which produce the copper sulfide. So the final product of the copper is converted to copper sulfide. So you use copper sulfide. So from this method itself, that sulfide impurities can be removed easily. So these are the separation and classification as well as the precipitation purity of the petroleum products. Then we may move on our combustion. So combustion is a process of burning in presence of oxygen. So whatever may be the material, so which is undergone the process of burning in presence of oxygen is called the combustion. So it is a exothermic chemical reaction. For example, copper plus oxygen gives copper. It is a exothermic chemical reaction. Example, carbon plus oxygen gives carbon dioxide, which with the release of 97 kilocalories of energy. So in combustion itself, the main factor is the air fuel mixture. So depending upon the air fuel mixture, we may find out how the quality of the fuel is there and how much it will be burned and how it may be utilized. So then we may know what is the air fuel mixture. So the mass ratio of air to fuel present in the combustion process is simply called as air fuel mixture. So we have to know about the mass of the air and fuel, then we may find out the ratio of the same. And air fuel ratio is the more important measure for the anti-pollution and performance tuning reasons. So by getting this air fuel ratio value, uh, we may understand that anti-pollution properties of that fuel. Then the main criteria is, if the exactly enough air is provided to complete burn all the fuel, the ratio is called as the stoichiometric ratio. So whenever we are using some fuel, depending upon the burning process, it happens either some residues will be there or not. So we have to know that in those cases, the stoichiometric ratio and the stoichiometric mixture is mainly useful. And by the combination of air fuel mixture and stoichiometric ratio, how the efficiency will be, we may find out those things and summarize that if the air fuel ratio is lower, its stoichiometric is a rich one and the efficiency will be somewhat less. So and the air fuel ratio is more higher, the stoichiometric is a lean and the efficiency is more. So by this combination itself, we may get which is the good fuel and which one give the maximum efficiency in during the process of burning in our internal combustion engines. Then the next one is the self ignition temperature. So what is meant by self ignition temperature? It is the temperature at which a fuel such as petrol or diesel spontaneously ignites in normal atmosphere without external source. So for an engine, if you are using as a fuel, we are igniting that one to burn this fuel. But in the case of self ignition temperature is at a specified temperature or as a lowest temperature, the petrol or diesel is spontaneously ignites without giving any external source. So which is mainly useful for its fuel property. So for example, the petrol having the self ignition temperature of 247 to 280 degrees Celsius, as in the case of diesel having the 210 degrees Celsius. So depending upon the self ignition temperature, it is used as a better fuel for internal combustion engines. And also we have to know about the explosive range or limit of inflammability. So depending upon these things, we may find out at which position it will get ignition and also getting burning. So which is this explosive range is the common factor for all fuels. So we have to find out those things. The volume of fuel present in the air fuel mixture is the explosive range. So find out that volume of fuel present in the system is the important one. And for example, the explosive range of petrol is 2 to 4.5. We have to check that in this range how the petrol is working. So how it will be ignite in those cases. So when the concentration of the petrol vapor in the petrol air mixture is below 2%, which is the lowest limit, above 4.5% is the upper limit. So the mixture will not burn on the ignition, it is when it is above in the 4.5%. So and also below in 2%. Simply we can tell, if we are taking a petrol, its explosive range is below 2%, it won't be useful. After 4.5% also it won't be useful. So it should be in the range of 2 to 4.5%. Then next thing, combustion in S engine. So combustion is differentiated in two types. One is the normal combustion and another one is the abnormal combustion. So what is normal combustion? When the flame travels evenly or uniformly across the combustion chamber. So while we are applying this, in this diagram shows us the combustion chamber. So in a normal combustion chamber itself, this flame is from the spark plug is uniformly distributed across the combustion chamber. This is the normal combustion engine. But in the case of abnormal combustion engine, when the combustion gets deviated from the normal behavior and resulting in the loss of performance or damaging the engine. So here we may check this is the spark plug, but the combustion happen in all over areas with a different direction. So so it will normally it will lose the performance of the internal combustion engine. So by comparing these two, normal combustion and abnormal combustion, normal combustion is the better one for our IC engines. So depending upon these, we may give details about the performance of the engine and the life of the engine also. Then comparison of abnormal combustion. So abnormal combustion also compared by two methods, that is the pre-ignition and knocking. Pre-ignition is the mixture of homogeneous Pre-ignition is the ignition of the homogeneous mixture of charge as it comes in contact with hot surfaces in the absence of spark. So the main importance is the which is giving a homogeneous mixture. In knocking is due to the auto ignition of end portion of unburned charge in the combustion chamber. And pre-ignition is initiated by some overheated projecting part such as spark plug electrodes, exhaust valve head, and metal corners in the combustion chamber. Carbon deposits are protruding cylinder, head, gasket, rim, etc. And the pressure and the temperature of the unburned charge increase due to the compression of burned position of the charge. This unburned compressed charge may auto-ignite under certain temperature condition and release the energy at a very rapid rate compared to normal combustion. Then auto-ignition may overheat the spark plug and the exhaust valve, and it remains so hot that its temperature is sufficient to ignite the charge in next cycle during the compression of stroke before spark occurs, and this causes the pre-ignition of the charge. This in knocking, the rapid release of energy during the auto ignition causes a vibration and pinging noise. From knowing that what is the fuel and what is the nature of the fuel and how it is going to burning in the process of combustion, which is used as in the some other cases. So depending upon these things we may find out the a perfect one for the combustion engine. Thank you.